KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, we are in a discussion the steps to be followed while solving a problem, physics problem related to mechanics. Okay, ma? So in our last class, I told you 3 steps, right? So when we are going to solve the problem related to mechanics, it is better to follow 5 steps to solve the problem as simple as such. Okay? So I will repeat the first 3 steps also. You just focus here. The first step is draw a diagram showing schematically the various parts of the assembly of bodies, the links, supports, etc. Right? So first we have to draw the diagram. First we have to draw the diagram including all the parts, including links and supports also, like thread or any person is pulling or pushing with the help of thread. That and all I should mention in the diagram. Next, second step is choose a convenient part of the assembly as one system. Choose a convenient part of the assembly as one system. Next, third point is draw a separate diagram which shows this system and all the forces on the system by the remaining part of the assembly. Right? So as simple as such, in third step he is saying that we have to draw the free body diagram including all the forces acting on the system. Right? Acting on the system, right? That he is saying. So we have to draw the free body diagram. So the first step is we have to draw the diagram by showing all the parts of assembly of bodies including links, supports. Second one is we have to choose a convenient part of the assembly as one system. Third one is we have to draw the free body diagram. We have to draw the free body diagram. Okay, right. Now we are going to say fourth step. See here, ma. In a free body diagram, include information about forces, their magnitudes and direction, because force is a vector quantity which has both magnitude and direction that are either given or you are sure. Either given or you are sure of. That is, for example, in the bracket he mentioned the direction of tension in a string along its length, right? So sometimes they have given, for example, gravitational force, that they may give, or otherwise we can find out because the gravitational force is acting vertically downward. Sometimes we have to know, for example, what is the direction of the tension in a string. So both either given or we are sure of, that we have to mention in the diagram. Okay, right. Next, the rest should be treated as unknowns to be determined using laws of motion. So out of the forces which are present, in the body, out of the forces which are present there, which are belongs to the system, some of the things are known, so they may give. Some of the things we have to find. So you can find the unknown force or the unknown quantity by using the laws of motion. So Newton's first law, Newton's second law and Newton's third law. Okay, right. Now I am going to show you fourth step, right? I am going to explain fifth step. See here, if necessary, follow the same procedure for another choice of the system. In doing so, use Newton's third law. Employ means use Newton's third law, right? If necessary, follow the same procedure for another choice of the system, right? So what is the system? You can decide ourselves, right? So that I discussed you in the third step and second step and first step, right? So based on the first three steps, we got an idea how to define a system. Sometimes by combining 2-3 bodies as a one system, and sometimes one body is like one system, another body is like another system, in that manner. Okay, right. In doing so, use Newton's third law, right? So what we are doing here, just we are following the procedure for another choice of the system what we followed for the previous system. Next, that is, if in the free body diagram of A, the force on A due to B is shown as F, then in the free body diagram of B, the force on B due to A should be minus F. So it is what? It is Newton's third law. Action is equal to minus reaction. So if one is capital F means the another one is minus F. But you have to remember that, see here, the force on A due to B is F means the force on B due to A is minus F. So in fifth step, he is saying that follow the same procedure, right, for different systems what you assumed in the given problem or in the given situation, whatever it may be. Okay, right. So before going to discuss the example problem, based on this information what we discussed, those are the 5 steps to be followed to solve the mechanical problem, to solve the problem from mechanics as simple as such. Okay, I will repeat once again those all 5 steps. Okay, so please be listen carefully. The first step is draw the diagram showing schematically the various parts of the assembly of the bodies, including the links, supports. So the first step is saying that draw the diagram of different systems, including all the parts of the system and links, supports, etc. Second point is saying that choose a convenient part of the assembly as one system. Choose the convenient part of the assembly as one system, right? So here we have to use our own experience, our own knowledge. If you want one body, you can take as a system. Otherwise, by combining 2-3 bodies, you can take as a system. Okay, right. Next, third point is we have to draw the free body diagram. Here itself, what is meant by free body diagram? As a picture or a diagram which shows all the forces acting on a body or system. A picture or figure which shows all the forces acting on a body or system is simply called as FBD, free body diagram. That is very important for us. That is very important for us. Next, fourth step. So what the fourth step is saying, right? Here direction of force is also important, right? At the same time, some of the forces given, some of the forces we have to decide. For example, direction of tension in the string. So in which direction the tensional force is present, we have to decide based on the situation. So in fourth step, he is saying that please try to give the magnitude and direction. If already they have given means okay, otherwise based on the situation, if is there any chance, we have to decide. Okay, right. Next, in the fifth steps, we are going to in fifth step, we are going to apply Newton's third law of motion. So which is also the part of laws of motion, right? So after completion of 5 steps, when you are going to solve the problem, definitely we have to use laws of motion, Newton's second law, Newton's third law and Newton's first law also. Okay, right. Now based on this information, we are going to discuss one example problem, right? Please concentrate here now. By understanding this problem, you can understand to solve any other problem related to mechanics. See this. A wooden block of mass 2 kg rests on a soft horizontal floor. When an iron cylinder of mass 25 kg is placed on the top of the block, the floor yields steadily and the block and the cylinder together go down with an acceleration of 0.1 meter per second square. Full stop. What is the action of the block on the floor? A. Before keeping the cylinder, and B. After keeping the cylinder. Right? So, before and after. Right? See here. So, before and after the floor yields. Right? So, if you understood the situation, you can find out what I need to calculate, what I need to do. So, given G value as 10 meter per second square, identify the action reaction pairs in the problem. So, this is also the task what they have given, right. So, what I am saying is you just focus here, I will repeat once again the problem. In physics, understanding of problem is very, very important. Without understanding the problem, you can't go for solution, right. So, please keep in mind what he has given, what he is asking to find. Okay, right. I will repeat once again. A wooden block of mass 2 kg rests on a soft horizontal floor. When an iron cylinder of mass 25 kg is placed on the top of the block, the floor yields steadily and the block and the cylinder together go down with an acceleration of 0.1 meter per second square. Right? We have to find what is the action of the block on the floor. A. Before yielding, B. After yielding. Asking to take G value as 10 meter per second square and also asking to identify the action and reaction pairs in the problem. Okay, right. Okay, now we are going for solution. So, when I am explaining solution also, you have to keep in mind what they have given in the problem, right. In case 1, like he kept only mass of 2 kg on the floor, but in case 2, I mean just I am separating. In case 2, he kept an iron cylinder of mass 25 kg on the top of the block, then floor is going to yield, and they have given the acceleration of system also. Here system means block plus cylinder, that acceleration is 0.1 meter per second square. Okay, right. See this. See the solution. First A. First we are going to talk about A. The block is at rest on the floor. Right. Its free body diagram shows 2 forces on the block. Right. One is the force of gravitational attraction by the earth, that you can calculate, that is like mg. That is like mg. Right. That is like mg. Right. Here you can see the free body diagram. Right. You know very well F is equal to ma. So, here F is equal to mg. So, mass into acceleration due to gravity, that is 20 newtons. That is 20 newtons. And the normal force are of the floor on the block by the first law. That by the first law, the net force on the block must be 0. Right. So, here observe carefully. Every word is important in this solution. Every word is important in this problem. You must be careful when I am explaining, right. See this. So, I will repeat again. The block is at rest on the floor. Next, its free body diagram shows 2 forces on the block. Next, the force of gravitational attraction by the earth equal to 2 into m into g. So, 2 into 10, that is equal to 20 newtons, and the normal force R, that is what capital R, the letter which are using to represent normal force. Normal force capital R of the floor on the block, normal force capital R of the floor on the block by the first law. The net force on the block must be 0 because the block is at rest now. It is not going down, it is not going up. Okay. So, then the net force on the block must be 0, that is R is equal to 20 newtons, because according to Newton's third law, action is equal to minus reaction. No, action is equal to minus reaction, right. So, when action is equal to minus reaction, the action is 20 newtons. For example, the weight of the block, right, that is what force of gravitational attraction by the earth is 20 newtons. Then automatically, that is what normal reaction is also 20 newtons. Normal reaction is also 20 newtons. Okay, right. Using the third law, the action of the block is 20 newtons, but it is downward. This is downward, right? And I already told you when I was explaining Newton's third law of motion, action and reaction are not constant. Between the two forces acting on two different bodies. I'll repeat once again. Between the two forces acting on two different bodies, if one is action, the other one will become as reaction, right? So keep in mind, so here he is taking the action of the block as the action of the block is 20 newtons. This is the force acting by the block on the earth, that is vertically downward. Then what about reaction? That is the force applied by the earth on the block. Okay, right. Now we finished A. Now we are going to see B, because two things are there now, right? In B, what we should do, After yielding, what is the action of the block? This is what before yielding. Now we are going to see after yielding what is the action of the block. Okay, right. You can see two pictures here, So one is this one. Here it is the block, and on the block he kept a cylinder. Right. It is also the same thing, but it is the free body diagram of the system having or consisting block and cylinder. So here written clearly FBD, free body diagram of block plus cylinder. Okay, right. So what I am saying is here, in case of this, that is what a system having cylinder and block. What I am saying is, when he kept cylinder on the block, then it accelerates downwards with 0.1 meter per second square. 0.1 meter per second square. Okay, and this is the free body diagram for the system consisting block and cylinder, right? So here itself, the force of gravity due to the earth is 270 newtons. Why it is 270 newtons, The mass of block is 2 kg, and we kept a cylinder, that is the mass 25 kg. So totally 2 kg plus 25 kg is 27 kg. 27 kg is the mass for the system consisting block and cylinder. Then automatically, according to that formula, F is equal to ma, here F is equal to mg, 270 newtons. 270 is the force of gravity due to the earth, right? Okay, and that is what floor is yielding here. That is very important point. When the floor yields, right, to find out the normal reaction, by the floor, so what is that? Newton's second law of motion. That is what? See, downward force minus upward force. Upward force is R dash, that is the reaction by the earth on the system, right? So 270 minus R dash is equal to 27 into 0.1. 27 into 0.1, right? Here one important point is, we should not keep the internal forces in your mind. You have to consider only the external forces, right? Okay. So what I am saying is, here just you have to apply the Newton's second law of motion. Then you can write it as 270 minus R dash. 270 minus R dash is equal to 27 into 0.1 from free body diagram of block plus cylinder. You may have one doubt. Why I am writing 270 minus R dash? Why not writing R dash minus 270, right? That is based on the situation. That's why every time I mention, so based on the given or based on the situation. Here the floor is yielding. The floor is yielding. When floor will yield? When the downward force is greater than the upward force. That is the reason we are writing 270 minus R dash, that is equal to 27 into 0.1. So mathematically you can find out the R dash value, it is 267.3, right? 267.3 newtons. It is what in the bracket I have written, action of the floor on the system. Action of the floor on the system, that is vertically downward. Here itself I am repeating one point that I already told you in the same class. That is what action and reaction are not constant. If one force is action, the other force will become reaction. And one more point here itself is action and reaction forces always acting on two different bodies. According to Newton's third law of motion, action and reaction are the two forces which are acting on two different bodies, right? So B completed now. Now we are going to see this is what identify the action reaction pairs in this problem. Identify the action and reaction pairs in the problem, right? Now I will tell you action and reaction pairs, you just please concentrate. So for A, right? So for A, what are the action and reaction pairs? Okay, see here, the force of gravity on the block by the earth. The force of gravity on the block by the earth is action means the force of gravity on the earth by the block. The force of gravity on the earth by the block is reaction. Okay, and these two also equal to 20 newtons. Action is equal to minus reaction, no? So magnitude is same, but direction will be different. One is downward means another one is upward, right? So this is one pair, ma. What is one pair? Force of gravity on the block by the earth, it is action, and reaction is force of gravity on the earth by the block. It is one pair. Another pair is here, the force on the floor by the block. The force on the floor by the block is action means the force on the block by the floor. The force on the block by the floor is reaction. So these are the two pair, right? Action and reaction. This is one action and one reaction, and this is action and respectable reaction, right? So when action is there, reaction is there. That is what according to Newton's third law of motion. So these are the action reaction pairs in case of A. Now I am going for B. See this. So this is the B, ma. See here. So here the first action reaction pair is force of gravity on the system by the earth. It is like action means force of gravity on the earth by the system. On the earth by the system. It is like reaction, right? It is action, it is reaction. It is one action reaction pair. Next, here, second thing, see this. It is what? Force on the floor. Force on the floor by the system. Force on the floor by the system is equal to force on the system by the floor, right? I will repeat once again. Force on the floor by the system is equal to force on the system by the floor. It is one action reaction pair. Next, what is the third one? See here, right? Force on the block by the cylinder. These two. Force on the block by the cylinder is equal to, it is what like action means the next one is reaction. That is what force on the cylinder by the block. Force on the cylinder by the block, right? So these are the action reaction pairs in case of A, and these are the action reaction pairs in case of B, right? Okay. But at the same time, one more important point we have to discuss for sake of better understanding, that is the solving of a problem in mechanics, right? We have to discuss what are the forces which are not action and reaction forces. What are the forces which are not action and reaction pairs? Okay, that also we have to discuss, right? I will tell you. See here, ma. Two forces on the same body, two forces acting on the same body, right, can never constitute action reaction pair. That is already mentioned in case of Newton's third law. But if you see such type of forces here, the force of gravity on the mass m, okay, right, whatever it may be the mass, the force of gravity on the mass in A or B, and the normal force on the mass by the floor, right? One is force of gravity on the mass in A and B, and the normal force on the mass by the floor. So these are not action reaction pairs, right? Because these forces happen to be equal and opposite, but because why actually equal and opposite? The mass is at rest. Mass is at rest, but because of acting on the same body, we cannot treat as a action reaction pair. Action reaction pair. Okay, so that is so because if you observe this problem here, we drew free body diagram. So whatever the steps I explained, 3 steps I explained in previous class and 2 steps in this class, these 5 steps we followed here to solve the given problem. So in this problem we did 3 things. One is, in case of A, in case of B, that is what before yielding and after yielding we calculated, right? We calculated, that is what action and reaction, right? So he is only asking now what is the action of the block on the floor before and after the floor yields, before and after the floor yields. Okay, right. So this is all about the concept, that is what solving problems in mechanics, right? So in our physics, you know very well, even NEET point of view also, there are 45 questions. So 40 questions problems, only 5 or 6 theory questions. That's why solving of problem is very important task for us, right? So especially this concept, definitely can expect one question. It is from laws of motion related to Newton's 3 laws of motion, right? When we need to solve such type of problem from mechanics, which is an important and oldest branch of physics, these 5 steps are important, right? Initially you may feel that these 5 steps are giving much information, but it is very simple. These 5 steps are very simple. You will feel as much as easy when you are going to solve more number of problems. It is the first problem in board point of view I am explaining you, right? So after completion of this, you are going for next problem and next problem. By solving more number of problems, you will feel more comfortable because of these 5 steps what I explained. Okay ma? Right. So here we have 2 steps. In our previous class I explained you 3 steps. These 5 steps here we are applying in this problem, right? In this problem, just they have given one wooden block of mass 2 kg kept on a horizontal floor. That is the case 1. Like next he kept an iron cylinder of mass 25 kg on the same block. Now the floor is going to yield, right? So before yielding, after yielding, what is the action of the block on the floor? That he is asking, right? To solve this problem, he has given some constant value, asking to take g value as 10 meter per second square, and also he is asking identify the action reaction pairs in the problem, right? See here, this is the free body diagram. In case of A means just when the block of mass 2 kg kept on the floor. In this case, right, you can find out the gravitational force, that is F is equal to mg, 2 into 10, 20 newtons, right? Then automatically you can find the normal force, right? It will be according to Newton's third law of motion, action is equal to minus reaction, right? So it is also equal to 20 newtons. Now we are going to see B, that is what after yielding. So whenever you are going to keep a cylinder of mass 25 kg on the block of mass 2 kg, the floor is going to yield. So they have given acceleration also, it is 0.1 meter per second square. According to Newton's second law of motion, you can write this expression. While writing this expression, you may have doubts. So why we are writing 270 minus r dash? Why can't we write r dash minus 270, right? So because the gravitational force is acting vertically downwards, right? So the floor is going to yield. That is the reason, first gravitational force, then minus normal reaction of the system. System means here block plus cylinder, right? So when you are going to write like 270 minus r dash is equal to 27 into 0.1, mathematically r dash value will become 267.3 newtons. Okay, so this he is asking to find, that is what is action of the block. Here itself I already told you, but once again I am repeating. In case of Newton's third law of motion, action and reaction forces are not fixed. If one is action, another one is reaction. At the same time, you have to remember one more point, that is action and reaction forces will not act on the same body. Action is acting on one body means reaction force will act on some other body. Okay, right. So afterwards he is asking to identify action reaction pairs. So these are the action reaction pair, and it is also another action and reaction pair in case of first one, that is what A. This is what action reaction pairs in case of B. Okay, right. So like this we have to solve the problem related to mechanics. Okay, thank you.